Hello, problem solvers. Here is another geometry problem. Okay, you have a square and it is divided into 5 rectangles, such that the 4 rectangles on the outside, these 4 rectangles have equal areas. Okay, prove the rectangle in the middle is a square. Please give this problem a try, or 2 tries, or 3. Okay, then you can appreciate this problem is quite tricky. Okay, I often I like these problems that are on one side. If you don't know the solution, if you haven't cracked it, it just looks impossible. Okay, but on the inside, after you know how to solve it, it's very short. Okay, I like these kind of problems very much. And here is one. So the hard part is that we are only given that these are rectangles and they have equal area, but we want to show this is a square. That means we want to show all 4 sides have same length. Okay, because you can see it is a rectangle already. So let's try to let's start. Well, let's begin by letting the S be the side. Okay, and let the shorter size of the rectangles be as shown. So let's call these, so the total is SE. If I call this A, this is the shorter side, this will be A, and this will be S minus A, this will be B, then this will be C, this will be D, this is S minus B, S minus C, S minus D. Okay, we are given that A times S minus B is the same as B times this, same as C times this, same as D times this. Okay, and we want to show that. So imagine if all 4 sides are equal, then what happens? Well, this what is this? This is S minus A minus C. If this is equal to this, that means S minus A minus C is equal to this, which is S minus D minus B. Right? And then this, and then we want to show, well, this is just one side, right? And we can compare this with this. So S minus A okay, if you compare these 2 sides, okay, then you can see that this is equivalent to A equals B. Okay, if you compare this one with this one, this will be S minus B minus A, and then this is equivalent to A equals D. And if you compare other sides, in the end you see that if it is a square, then these 4 values should be equal. So that's what we want to show. Right? If we can somehow show that A equals B equals C equals D, then we will have proved this statement. But we just have this 4 or we just have this condition. Okay, that is the challenge. This is the core of the problem. Given this condition, can we show this? You can pause the video and give it a try. Okay, that is, you can ignore all the square, everything. Okay, just focus on these two. That is the core of the problem. Okay, given this condition, how do we show it is all 4 values are equal? Okay, if you have tried to derive some more relationships, okay, you just end up doing algebra a lot, and it will lead you nowhere. So and that's why this is a problem worth looking at, because its solution is quite outside the box. So imagine here, that's what we want to show. We want to show A equals B equals C equals D. A standard technique to show something is to assume the contrary, okay, proved by contradiction. So let's assume that's not true. So if that's not true, that means at least 2 values, at least 2 variables are unequal. Okay, but that wouldn't give you much handle to work with. Whenever you consider the contrary, if they are unequal, that means there should be a biggest value and a minimum value. Okay, so let's say rho log means without loss of generality. Let's say A is the maximum. Okay, that's all we can say. We cannot say, oh, B should be the minimum, or C or D. We cannot say that. Okay. Maybe not, but we can always assume one of them is the maximum. Okay. So we can begin with this condition, and I know that A is bigger than D. And because A is biggest, S minus B should be bigger than S minus A. But we are back to the origin. So if these two are the same, then both of these inequality must be equality. So that proves that A is D and A is B. Of course, we can also now we can go on. Okay. If this is A, then you can find out C is also A, and that's the solution. That's what we want to show. Right, so S minus A equals A S minus C, so that gives us C equals A. So we have proved that all of them are equal, and that's why the middle is a square. Solution is very short. But if you are not aware of this kind of technique, this is called, well, the thinking is like consider the contrary, okay, or consider the extreme. This is the technique of considering the extreme, okay. Yeah. So but without this technique, if you don't use this, if you don't attack the problem in this direction, I'm not sure if there is another direction that you can find out from this condition and will lead you to this. So this technique, consider the extreme or consider the contrary, is really like a very general strategy. You can use it on geometry problem, you can use it on algebra problem, you can use it on number theory or combinatorics problem. So these are like keep this in the back of your mind, okay, whenever just trying the standard way gives you no improvement, then you should think about this general strategy. That's the lesson of this problem. Okay, let's finish this with a difficulty rating. About 5. So a typical Olympiad level. 4 to 5. Yeah, let's just say 5. And so the character would be Sasuke. Chitoli. Thank you for watching.